Hi everyone. Today we're going to solve a problem involving the second law, Newton's second law, specifically a dynamic equilibrium. Usually when we don't have motion, we have that the sum of the forces are equal to zero. That's static equilibrium. If we have motion, we call that we say that the sum of the forces are equal to the sum of the effective forces. And the effective forces are represented by the kinetic diagram, whereas the sum of the forces are represented by the free body diagram. So in this problem here, if we have a body that has a mass of 8 kilograms and is being applied a force of 400 newtons with an angle of 45 degrees, and we know the coefficient of kinetic friction as 0.20, and then the problem asks for the acceleration, we can divide this problem into two parts. First is the free body diagram. The free body diagram will represent just the forces that are being applied, the external forces that are being applied on the body. We have here 400 newtons, and the angle is 45 degrees. We have the weight of this body. We're going to call that W. What else? We have the normal force, N, and we have the friction force. The friction force is always directed to the opposite direction of motion, and we're going to call that F. Now, this is if the body was at equilibrium. That's our free body diagram, and it's going to be equal to the motion, because this body is not static. That's why we call it a dynamic equilibrium. This is going to be able to a motion. As we can see, the force is going that way, therefore our motion is going to go that way as well, and that's going to be m times a. That's our motion. And this diagram we call the kinetic diagram. When we equate these diagrams here, we have that the sum of the forces in the y direction are equal to 0, because we don't have any motion in the y direction. So in this case, we equal this to 0. And why do we do that? Because we want to first find the normal force and then use that to find our acceleration. For the forces in the y direction, we have n, and then our direction, our positive direction, we're going to assume going up, so that's going to be n plus 400 times, if this is a 45-degree angle and we want just the vertical direction, we multiply 400 times the sine of the angle, and then minus the weight. That's going to be equal to 0 because there is no motion in the vertical direction. If we isolate n, we have W, which is just the mass times gravity. We have that the mass is 80 times gravity, that's 9.81, minus 400 times sine 45. If we do the math here, we have that n is equal to
502.
502. Thank you, sir. Okay, after we find the normal force, we can use the same diagram, but now do the horizontal direction. And the horizontal direction, we have motion. So we have that the sum of the forces in the x direction, assuming that this way is positive, is equal to the sum of the effective forces in the x direction. And effective forces just means that is the resultant that's causing motion. Because if it's 0, then we just equal that to 0 as we did for the vertical direction. If we have motion, then we do the effective forces. In our case, we have 400 times now the cosine of 45. That's the force acting in the horizontal direction, minus force of friction. That's going to be equal to m times a, which is our resultant. M times a. We have m and we want to find a. For the force of friction, we can substitute here the equation for force of friction. Force of friction is defined as mu times the normal force, and we found the normal force from the first step, equals ma. So now we can say that a is 400 cosine 45 minus this guy here, 0.20, times normal force, which is 502, divided by our mass, which is 80. Now we just plug it all in and we find our final acceleration,
2.28,
which is 2.28. And the units for our acceleration is meters per second squared. And the direction is going to the right. If we found this value as negative, that would mean that our initial assumption here is wrong, and then the direction would be the opposite. But because it's positive, it means that the initial assumption that we had is correct. So this is our final answer.